everyone, in this video, I'll be showing you how to use a BioCompute object with an embedded CWL workflow. For this tutorial, we will be using an example BCO with an embedded two-step CWL workflow that was created by Hadley King. I will link the GitHub repository that contains this BCO and any relevant files such as the workflow or the YAML file or any input files or any tools in the description. We can look at the usability domain to give us a human readable overview of the workflow. So we see our workflow, we run blastn to identify homologs, and step 1 is to make the BLAST database, and step 2 is to run nucleotide BLAST. So we know our BCO is a CWL workflow. We can see it in the platform, which is CWL, which says where the BCO can be reproduced. We can see it in the keywords associated for searchability and description. One of our keywords is common workflow language. We can see it in the script driver, which is the executable to be launched to run the pipeline steps. In our case, it's CWL to run a CWL workflow. So we know we have a CWL workflow in our BCO, but how do we put all the components together? First, we look at the software prerequisites, which tells you the software needed for the workflow. So we need CWL tool, which makes sense. It's our script driver. We need it to run the pipeline. And we also need BLAST. URIs are provided to download the software. We need to get all of our scripts. The scripts are used to perform computation for the BCO. So that is our CWL workflow, which is the blastn homologs.cwl. We know from reading our usability domain. We need our command line tools, which is blastn.cwl, step 2. On make blastdb.cwl, step 1. We know that from our usability domain, but we could also look at pipeline steps, which I'll show you in a second. Or we could look at our workflow itself. And it also has the YAML file, which is used for the input. Speaking of input, we need to get any of our input files. So they're the files that are needed to run the CWL workflow. And the URIs are provided, so you can just download them from there. So as I mentioned earlier, the pipeline steps can be useful to verify the steps in the workflow. You can check the order and the output of steps. And if no CWL workflow is provided, only the command line tools, you need this part to put the tools in the correct order. So as we can see, step 1 is make blastdb, step 2 being blastn. So we would have known that even if it wasn't in the usability domain. Okay, so the steps together. Make sure you have the proper software prerequisites, collect any input files listed in input subdomain, collect any of the scripts listed in scripts, make sure everything is in the correct location. So tools need to be correctly referenced in the workflow, the correct path, and input files need to be correctly referenced in the YAML file so it can find what you're referring to. And then at this stage, you can just run the workflow passing the YAML file. So showing you what that looks like. In our case, all of the things were in the GitHub repository, so I didn't download the URIs individually, I just cloned the repository. So as you can see, I have everything in the correct place. So I'm going to go into tests, and I'm going to go into BLAST, which has the workflow, and I am going to run the workflow. So with CWL tool, which I downloaded earlier, along with BLAST, my prerequisites, I'm going to run the workflow, which we've identified as blastn homologs.cwl. I'm going to pass the input file, and then I'm going to run it. So as you can see, everything runs great. And then I can check my output just to see if it looks correct. And it does. It looks great. Well, that was easy enough, but is there an easier way, a way that saves even more time? Luckily, there is. In that repository that I have linked in the description, there's also a tool called the BCO tool. It offers many awesome functionalities for manipulating BioCompute objects, one of them being that it can automatically run a CWL workflow that's embedded in the object. So can take a look at the repository. There's a README that tells you how to install the tool. 6 super easy steps to get it set up. And you might already have the repository cloned for this tutorial. Okay, so now let's see what it looks like. So I already set up the tool. So BCO for me will run the tool. And now I want to see run CWL to see what input I'll need. Okay, I need to pass a BioCompute object. That makes sense. So I'm going to pass the BioCompute object that we've used in this description. It's a slightly updated version. Okay, great. So it is able to run it. It's able to pull any of the files from the URI that are referenced in the BioCompute object, and it's able to run the workflow. So it's able to do what we were doing manually itself, and it does it really quickly, low effort. So you can see step 1 completed successfully, step 2 completed successfully, final process is a success. Okay, thank you for watching.